Hello everyone, today I'm going to present the paper LLM for Fin, fully automating LLM-powered test case generation for fintech software acceptance testing. This is an good work that proposes a fully automated method for generating test case in fintech software, a domain where both accuracy and speed are very important. To understand why this work is important, we need to start by looking at the challenge faced in fintech software development, particularly when it comes to the accept testing. Fintech software powers important financial services like stock trading, fund management. These systems are unique in that they operate under a structured regulation framework, where even a small mistake can lead to huge financial loss or legal penalties. Because of this, the testing process of such software might be throughout ensure compliance with a wide range of business rules and regulations. Acceptance accept testing is a key part of this process. It involves verifying that the software meets all the specific requirements, often described as regulations or business rules. These rules are typically written in a natural language and can quite complexity. For example, a rule might state if a merchant trading method is adopted, the declared quantity of cash bond shall be 100,000 yuan in face value and an integral multiple thereof. Now imagine manually generating test case to cover all possible cases for hundreds of such rules. It's a hard task, but currently this process still relies heavily on human testers who must interpret these rules, identify each case, and write the test case manually. First, consider the nature of business rules and themselves. These rules are typically written in natural language, which is ambiguous and open to interpretation. The manual extraction of these rules is error-prone and time-confusing. Secondly, the process of generating test cases manually requires significant human knowledge. Testing engineers must be familiar with fintech regulations, understanding the logical rules, and identify possible test cases. They also need to design test cases that ensure comprehensive coverage. This level of demand means the process is not only slow but also difficult to scale, especially as the complexity and the scale of the rules grows. As the finance market develops, these rules are frequently updated, adding to the workload. Clearly, there is a strong need for automation. At first thinking, large language model seem like a good fit for this problem. They can process and understand natural language, making them ideal for interpreting business rules. However, there are significant challenges when it comes to using large language model for test case generation. Large language model rely heavily on well-crafted prompt to generate meaningful output. Generating this prompt requires domain knowledge and technical skill, making the process demanding even for experienced testers. Secondly, even with good prompt, large language model can produce output that's incomplete. For example, when asked to generate a test case, a large language model might focus on subset of the rules while ignoring other important aspects. This inconsistency makes it challenging to ensure readability and reproducibility. Thirdly, generally proposed large language models like ChatGPT are trained on many datasets, but often lack the specific knowledge required for domain like fintech. As a result, they may fall into interpret domain-specific term or generating good test case. So to summarize this problem, the traditional approach to accept testing is slow, manual, and result intensively, while large language model offer possible solutions, their limitation, dependency on prompt, or output inconsistency, and lack of domain knowledge affect their effectiveness. In short, the motivation for the work lies in solving three important problems: reducing the time and the effort required for fintech software testing, improving the accuracy and reliability of test case generation. And thirdly, we need to enable scalability in a domain where complexity of rules continue to grow. And now we have know the challenge in fintech step testing and the limitation of current approach. Let's discuss the solution proposed in this paper, LLM for Fine. This framework is fully automated method for generating high coverage test case for fintech software. It combines the large language model processing capability of large language model with the accuracy and the predictability of algorithmic method. LLM for Fine address the three main problems we discussed earlier. The solution involve a system process that combines the strength of large language model with a deterministic algorithm to ensure the reliability and scalability. Generally, this framework has three parts. So let's go to each part in detail. First is the rule extraction part. The process begins with identify testable rules from natural language documents. This document often contain a mix of testable rules, background information, and terms. Using a fine-tuned large language model, LM for Fine, filter out irrelevant contents and extra testable rules. For instance, if a document contains a rule like the declarable quantity must be an value multiple of 100,000 yuan, LM for Fine will identify this as testable. Then the extracted rules then transformed into a formalized structure that the algorithm can process. This involves breaking down the rules into key value pair, such as the trading method, declared quantity, and their respective constraints. And the second part is the scenario generation. Next, LM for Fine uses domain knowledge to interpret and operate the formalized rules. This step ensures that the abstract terms are made concrete and dependency among rules are identified. For example, if a rule refers to other trading method, LLM for Fine using a predefined knowledge base to replace them with specific method like bidding trading or negotiation trading. This step also involves mining relationship between rules and ensure that all necessary scenarios are covered. For instance, if one rule depends on the outcome of another, the system creates a test case that accounts for this dependency. And the third part is what we want, test case generation. Finally, LM for Fine generates the final test case. This is done by applying well-established testing strategy like boundary value analysis and equivalence partition. For example, if the rule specific the valid quantity must be multiple of 100,000 yuan, the test case would include a value like 100,000 yuan, which is a variable case, and 200,000 yuan, where is also a valid case, and also it will get a 15,000 yuan, which is invalid case. These test cases are generated systematically ensure high coverage of all possible scenarios. And and so let's make a conclusion. What makes LM4 Fine stand out is its ability to combine AI and algorithm at the same time. Let's highlight a few innovation in this framework. First, LM4 Fine fine-tune pre-trained large language models such as GPT-4 to specialize in fintech rule extraction. This significantly improve accuracy compared to general proposed method. Secondly, while large language model handle the natural language model interpretation, algorithm ensure that the outcomes are deterministic and reproducible. This addresses the inconsistency issue typically seen with large language model. Thirdly, unlike traditional methods that rely humanly on human intervention, LLM for Fine automates the whole process from rule extraction to test case generation. This architecture is the backbone of LLM Fine success. By dividing the process clearly, system step and leveraging the best of both AI and algorithm, LLM4 Fine achieve results that set a new standard for fintech software testing. Next, let's move to the result and evaluation, and we will see how this architecture performs in practice. And the performance of LM4 Fine is evaluated using three important metrics. The first is business scenario coverage. This metric ensures how thoroughly the generating test case covers the possible business case defined by rules. High BSC indicates that the system is effectively covering a wide range of software requirements. And the second metric is code coverage. We call it SBC. SBC stands for statement block coverage, which check how many code statements are executed by test case. Also we will check the MCDC. MCDC stands for the modified condition and decision coverage, which measures whether all possible logical conditions in the code are tested. And the third is general the time efficiency. This measures the time required to generate a test case compared to manually method or other automated approach. And in this paper, they compare the LM Fine against four baseline. First is expert tester, and the second is non-expert tester, and the third is ChatGPT. Fourth is ChatGML. This compared with this baseline allow us to evaluate LM4 Fine performance against both human and automatic benchmark. And firstly, the author provide 5 datasets, each contain rules from different fintech domains, such as stock trading and or convertible bond. Here is their key finding. Their key findings. First, we can see that LM4 Fine achieve BSC rate exceeding 18% across all datasets, with a maximization of 98.18%. In construct, expert test averaged 75.16, while ChatGPT and non-expert only got 69% and 63%. And uh, then and after that, also evaluate how well the test case execute the real software code. This was measured on the most uh, complex dataset 5, which had 400 billion business scenarios. Here is what's their result. We can see that LLM for fine achieve 93% SBC and 19 MCDC. It gets the best performance among all methods. In comparison, expert tests only achieve 19.6 SBC and 18.2 MC and DC, while ChatGPT get the 19.7 SBC and 18.7 SBC and 18.1 MC and DC. We can see that LM for fine got a great code coverage, shows its ability to produce test cases that not only meet business requirements but throughout test the underlying code. And the third, it is the report of the time efficiency. Time efficiency is an important factor in software testing, especially for fintech systems via rapid development. So here is the large language model for fine performed. We can say LM for fine reduce the time required for test case generation from 20 minutes to just 7 seconds per rows. This efficiency makes it scalable for real-world application where hundreds of rows may need testing at the same time. And so let's make a conclusion. How does this result tell us? First is that LLM for fine high BSC and code coverage shows its ability to generate throughout and reliable test case. And second, the system largely reduce the time required for test case generation, making it highly practicable for fintech environment. And thirdly, LM for fine produce stable and reproducible output, addressing one of the major limitations of general purpose LM. And fourth, the system not only better than non-expert and ChatGPT, but also performance compared with experienced human tester, which shows its potential to further apply the framework in real-world application. In conclusion, this result shows that LLM for fine is not just an academic exercise. It's a highly effective tool for real-world fintech software testing. And then let's go to the next part. While large language for fine shows significant advantage in automating test case generation, it's important to note that the changes that arise during the development and real-world deployment. In this section, we will discuss some changes faced and how can they be addressed. And the first challenge it is the ambiguous of a natural language model, which makes it difficult to interpret business rules accurately. And for this challenge, we can address the challenge by fine-tuning pre-trained large language model specifically for the task of rule extraction. This model was trained on a domain-specific terms that include anominated business rules, enable them to identify and formalize testable rules with high accuracy. And the second challenge is the domain knowledge requirement. To solve this challenge, LLM4 Fine incorporates a domain knowledge base, which includes a predefined concept, relationship, and value specific to fintech. For instance, terms like bidding trading and clinical trading are clearly defined with a knowledge base. This knowledge is used to resolve ambiguities and abstract rules, ensuring that the system produces accuracy and good test case. And the third challenge is output consistent and readability. To address this, LLM4 Fine combines the flexibility of LLM with the predictable of algorithm. After the LLM extract and formalize rules, algorithms ensure deterministic and reproducible test case generation. For example, the system uses equivalence partition and boundary value analysis to systematically cover all possible cases and to animating gap in coverage. And the challenge 4 is scalability. To solve this, LM4 Fine fully automated pipeline process rules in parallel, in making it possible to handle large data set efficiently. Addition is a rapid exclusion generation test case in seconds, making it scalable for real-world system. And the challenge 4 is data privacy and regionalization constraints. To solve this, LLM4 Fine can be deployed locally with an organization ensure compliance with data privacy regulation. Additionally, fine-tuned model can be trained on the user's own data without sharing sensitive information. And the last challenge is the adaptation in legacy system. To solve this, LM4 Fine's modeling architecture allow it to be adaptable to different software environments. For example, the rule extraction and test generation components can be integrated independently into existing test workflow, which is making this proposed method can be co-work with other good method. So currently we are near the end of the discussion, and it's important to consider the broader implication of LM4 Fine. Beyond its intermediate success in automating testing for fintech software, the work is also be applied for other domains such as healthy care. In healthcare, software system must combine with regulations such as SIPPA or FDA requirements. LLM4 Fine approach could automatically the testing and electronic health record system ensure compliance with medical standard. And the second application is automatic visionist. We know that automatic driving software rely on strict rules for safety and decision making. LM4 Fine could be used to generate test case for senior for senior in the automatic driving system. And the third part is the e-commerce For online shopping platform, business rules often involve pricing, promotion, and shipping policy. Automatically testing case generation in this domain could enhance the accuracy and reliability of online shopping platform. And LLM will find also highlight a key trend in software testing, the integrating of AI with deterministic algorithm. This approach has several applications for the future. The first is improve the test quality by navigating domain knowledge and structured algorithm. AI-driven testing framework can produce higher quality test case with fewer error compared to manual or fully AI only method. And the second aspect is increase the automation. The end-to-end automation shown by LM45 could inspire the development similar framework for other software engineering tasks such as code generation, debugging, and performance optimization. And the third is customizable AI model. The success of fine-tuned large language model for domain-specific tasks suggests that future AI systems would be increasingly specialized, leading to better performance and greater adoption in specific fields. And finally, it is a future research direction. The author, this paper identifies several areas where further research could be enhanced the capability of LLM for fine and similar systems. The first is multi-domain training, developing LLM that can operate across multiple domains without requiring extensive fine-tuning. And the second is enabling system to learn and adapt new rules and scenarios dynamically without retraining. And the third one is improving the interpretability of AI-generated test cases to help human testers understand and trust the output. And the last one is integration with CI and CD pipeline. Integrating automated test case generation into continuous integration and deliverable workflow for real-time testing. So then we can make a final summarize LM for fine combine AI with deterministic method for testing generation. It achieves high coverage, efficiency, and scalability. This method open a new avenue to fintech software testing and set a benchmark for other domains. That's all. Thank you.